Alright, hello everyone. In today's video, we are going to be deriving the lever rule over here for this pressure versus mole fraction graph over here that we created in the last video. And basically, what the lever rule is going to be, it is going to be a ratio of the moles in the vapor phase and the moles in the liquid phase. Alright, so we're going to be performing a mass balance, and at the end of it, we are going to want to find what V over L is, alright? That is going to be a ratio of the moles in the vapor over the moles in the liquid again. And so we're going to go ahead and jump into that now. So the first step we're going to do is that we know for a system, we know that the flow rate going in times the mole fraction of that flow is going to be equal to the flow rate of the vapor leaving times the mole fraction of the vapor plus the flow rate of the liquid. Times the mole fraction of the liquid. If you want more in-depth talk on that, we did discuss it greatly in the last video, so you can go ahead and check that out if you want to. Alright, and the equation that we have for that is T representing the flow rate going in times Zi. This is the mole fraction based off the more volatile compound, which in this case is benzene. So as TZI, and that is equal to the vapor times the mole fraction in the vapor. That's plus L times the mole fraction in the liquid, alright? And basically our next step is going to be to substitute in for T. We want to get this just in terms of V and L. And we also know that the total flow rate going in is going to be equal to just the flow rate of the liquid and the flow rate of the vapor going out. So that we know that T is going to be equal to V plus L. So we can go V plus L Zi is equal to Vyi plus Lxi, like so. And next thing we're going to do is we're going to want to go ahead and factor this out. Vzi plus Lzi equals Vyi plus Lxi. And what we're going to want to go ahead and do now is we are going to want to get all of the terms with L in it on one side and all of the terms with Y in it on the other side. So we'll go ahead and do that now. We'll get all of the L's over here on the left and all of the V's over here on the right. So we're going to go Lzi, and that's going to be minus Lxi. Is going to be equal to Vyi minus Vzi. And now we can go ahead and factor these L's and these V's out. So this is going to be Lzi minus Xi is equal to Vyi minus Zi. Alright, and now we can just go ahead and divide both sides by V and then divide both sides by Zi xi, so we can get that fraction, once again, that we were looking for, that V over L, to get this in terms of the moles going into the vapor over the moles going into the liquid. So we're going to go ahead and do that. Multiply both sides by L. We're going to get V over L over here on the right side. And then we're going to get Zi minus Xi over Yi minus Zi. And there we go. That is going to be our derivation for the lever rule. Okay, so now we're going to jump over here to this graph that we have over here. And this top line right here is that bubble pressure graph that we plotted earlier and a few videos ago. And this bottom line over here represents the dew pressure. And this is all at a constant temperature, all right? For this example, I believe it is 393 degrees Kelvin, all right? And so if we have any point that is going to be below this graph, that means that the mixture is going to be all vapor, all right? And anything above this means that the entire mixture is going to be liquid, all right? The point has to be somewhere between these lines in order for the vapor and the liquid to both coexist in the same mixture, all right? And for the specific example that we ran in the last video, we had a mole fraction of benzene at 0.4. All right, that means 40% of the mixture going in to our reactor was in fact benzene, and the pressure on it was 180,000 Kelvin right here, or not Kelvin, that should be PA right there. We'll get that written out, PA. All right, there we go. And now we're going to take a look at what this lever rule is telling us, all right? So this is telling us that the ratio of the vapor flow going out and the liquid flow going out is going to be equal to this Zi minus Xi over Yi minus Zi. And a good way to think about this is this Zi minus Xi is going to be the distance from the selected point all the way over to the left and until it reaches this bubble pressure graph. I know it's probably hard to tell. I'll scoot you guys in closer so that you can hopefully see this a little bit better. But we have a dot right here where this horizontal pressure line meets this bubble pressure line. And this distance between those 2 points is going to be represented by the Zi minus Xi. And over here, this Yi minus Zi is going to be represented by this, this line right here, all right? And this is because Zi is the middle point right here, all right? That is the initial concentration of benzene and going into the flow tank. And then this Xi right here, that's the concentration going into the liquid phase, and this Yi is the concentration of the benzene in the vapor phase. All right. So this is our Yi point, this is our Zi point, and this is our Xi point. All right. And a good way to think about this is why it's called the lever rule is because when you go up and down this way and this way, this percentage, or not percentage per se, but this ratio over here of the vapor and liquid is going to change with it, all right? So let's just say for a second that we went all the way up until this graph met at the boiling pressure, or not the boiling, the bubble pressure line. It met there. At that point, what we would have is that this Zi minus Xi would then be 0, all right? And that means also that this Yi minus Zi would be a lot bigger. And since we would get 0 over a large number, that means that we would have zero of the mixture left in the vapor phase, and it would all be in the liquid phase. And that makes sense, right? Because earlier we said that everything up above these graphs would be in the liquid phase. And basically what this is saying is that as soon as it reaches that point, that means that it's going to turn into all liquid. This is the point where the mixture reaches all liquid. All right, and on the other hand, if we go down here all the way up to where it meets the dew pressure line, that means that the Zi minus Xi would expand. And then this Yi minus Zi would go to 0. And that means that the mixture would then be all vapor. And once again, that makes sense because remember we said if the point is anywhere below the graphs, that means the mixture is going to be all vapor. And this point is where the last drop of liquid evaporates into vapor. Just like this point right here is where that last few molecules of gas condenses into the liquid. All right. And yeah, that's the lever rule for you. Basically, all the lever rule is saying is that as you change the pressure, right, you make the pressure go up and down, this ratio of the vapor flow and the liquid flow is going to change, and that's going to change based on these distances right here. So that's a good way to visualize the vapor rule. That's going to do it for today's video. Have a good one. Smash like and subscribe, and leave a comment if you enjoyed the video.